So example 3, we're given the system we had from the poster, 2x plus 2y equals 300, and x equals 4y, and we're asked to determine which of the following are solutions to the system. So a solution to a system with two variables is an ordered pair that makes both of these equations true. So a solution to a system are values of the variables that make all of the equations in the system true. In this particular system, there's only two, so I'm going to just replace the word all with both. So they've given us the point 100, 50. So keep in mind that our ordered pair is in the form x, y. So we're going to take our first equation, remembering to put parentheses around each variable before we substitute. And so in place of x, we're going to put 100. And in place of y, we're going to put 50. We're going to see if those values make our equation true. So 2 times 100, we get 200. 2 50s is 100. And so we get 300 equals 300, which is a true statement. All right, so this tells us that the point 100, 50 is a solution to this equation, to 2x plus 2y equals 300. But to be a solution to the system, it must also be a solution to our second equation. So let's try substituting these values in the second equation. So in place of x, we're going to put 100. And in place of y, we're going to put 50. So we get 100 equals 200, which is false. So 100, 50 is not a solution to our second equation, x equals 4y. Okay, so since this did not make both equations true, it can't be a solution to the entire system. So since 100, 50 does not make both equations true, this ordered pair 100, 50 is not a solution to the entire system. Okay, so what about the point 40, 10? So again, keeping in mind that this is an x, y. So let's try our first equation again, remembering to put parentheses around each variable before we substitute. So we're going to get 2 times 40 plus 2 times 10. So we get 80 plus 20. So we're going to get 100 equals 300, which is false. So this tells us that the ordered pair 40, 10 is not a solution to this equation, to 2x plus 2y equals 300. And we don't really need to check it in the second equation because there's no way it can be a solution to the system when it's already not a solution to the first equation. So since 40, 10 does not make both equations true, 40, 10 is not a solution to the system. Okay. So what about the point 120, 30? Again, keeping in mind that this is an ordered pair x, y. So again, we're going to take our first equation, remembering to put parentheses around each variable before we substitute. We get 2 times 120 plus 2 times 30, and we want to know if that equals 300. So we're going to get 240 plus 60. So 300 equals 300, which is true. Okay, so our pair made our first equation true, so we know that 120, 30 is a solution to this equation, 2x plus 2y equals 300. But to be a solution to the system, it has to make all equations in the system true. So let's try our other equation. Again, remembering to put parentheses around each variable before we substitute. So x equals 4y. We're going to plug in 120 for x. And we're going to substitute 30 for y. And we get 120 equals 1 120, which is true. So this tells us that 120 comma 30 is a solution to this equation, to x equals 4y. So this ordered pair is a solution to both equations in our system. So it's a solution to the system itself. So since 120 comma 30 makes both equations true, 120 comma 30 is a solution to the system of these two equations. Okay, so this tells us that if we had our poster was 120 by 30, it would meet the criteria where the perimeter was 300 and the one where our one dimension was 4 times the other. So it's easy enough to check if a given point is or is not a solution to a given system of equations. We just substitute the values and we see if the ordered pair makes all of the equations true or not. But finding the points that are solutions is a bit more difficult. So in this chapter, we will discuss 4 ways to solve a system of 2 linear equations in 2 variables. So in this section, we're going to be focusing on the graphing method. So this method involves graphing each of the equations in the system. The table method, so we looked at input-output tables in the last unit. So this method involves making an input-output table. And then in the next section, we're going to look at the substitution method, which involves substituting the value of one variable from one equation into the value of that same variable in the other equation. And then finally, we're going to look at the elimination method. And this involves adding equal quantities from each of the 2 equations together to eliminate one of the variables and end up with one equation and one variable, which we learned how to solve in the last unit.